Welcome back everyone to another one of these. So we're going to just finish off the graphs, and then apparently Evie had a hard question for us to have a go at. And then next week we'll probably do that predicted paper that I made for you guys. So I have actually got it fully created now, and I'll be able to put it on somewhere for you guys to download it too. So we'll continue where we left off. So it says here we've given a quadratic graph here, and it shows part of the curve with equation y equals f of x, and the maximum point are 3, 5. Write down the coordinates of the maximum point of the curve when the equation is y equals f of x plus 3. So if you remember, if it's inside the bracket, it affects x and it does the opposite. So the opposite of adding 3 would be take away 3, and it affects x. So take away 3 from x. The x coordinate here is 3 and the y is 5. So what we're going to do is take 3 away from 3, which is 0. And the y coordinate will stay exactly the same. So hopefully that's just a bit of a recap or a reminder. For the next part, it says 2f of x. So again, it's outside of the bracket, which means it affects y, and it does exactly what it says. So this is 2 times, and it affects y. So all we're going to do is times y by 2. So again, the x coordinate will stay identical, and the y coordinate will become 10. Okay, so I think so far it's pretty okay. Lastly, we have f of 3 of x. So again, it affects x, but it does the opposite. So instead of 3 times x, it's going to divide x by 3. So 1 and 5. So is that all okay so far? So again, hopefully not too bad. This is from the 2015 paper for Edexcel. Just 1 mark per thing. Not too shabby. And again, inside the bracket it affects x, and you do the opposite. Outside the bracket it affects y, and you do exactly what it says. Okay. Lastly, they give you a bit of a wordy question instead. So the curve with equation y equals f of x is transformed to give the curve y equals f of x minus 4. Describe the transformation. All you would describe it as is a translation, because that's the type of transformation it is. So that would give you 1 mark, and the second mark will come from what it is. So translation 4 units downwards, okay? And it's downwards because you're subtracting y by 4, okay? If it was affecting x, you'd say it's translation 4 units left or right, and if it was plus 4, it would be translate 4 units upwards. So you should be able to actually describe all of these transformations in terms of words. So are we all okay with that? So for example, 2f of x, would you be able to say that, say what transformation is in words? Or would you like me to go through that? You know, it might be good to go through. Anyways, let's go through it. So for part I, if I were to describe this transformation in words, it would again be a translation. Yeah, go through, okay. So again, I'm subtracting 3 from x, right? So all I'm doing is I'm moving the whole thing left or right. So if I were to draw this graph, f of x plus 3, the new maximum would be here, because that's 0, 5, right? But the overall shape would stay exactly the same. Just imagine it looks exactly the same. So it's just a translation, right? I'm just taking it and I'm dragging it left, right, up or down. So for this one, it would be a translation. So again, that's 1 mark. 3 units to the left, because all I'm doing is I'm moving it 3 spaces to the left. Are there any questions about that? So again, if it's outside the bracket or inside the bracket, if you're just adding or subtracting numbers, it doesn't matter if it's inside or outside the bracket, it's a translation. Okay? So maybe I should actually add that. So inside or outside the bracket, adding / subtracting is just a translation. You're just taking the graph and sliding it about, right? Now part 2, you're actually multiplying, right? We multiply all of the y values by 2. So this is actually an enlargement, okay? Enlargement of y-axis by scale factor 2. Okay? Because again, we're taking the y values and we're stretching it. Okay? You can also say, so you could also say, so I'm going to write or stretch in y-axis by factor of 2. That is also acceptable. I would prefer to write this just because enlargement is an actual transformation. Stretching technically isn't a transformation, but they do accept it. Okay? Just FYI. So if you have negative scale factors, you begin counting from the shape or from the center. As in, if you normally just have a scale factor, so like if they gave you a square and they said enlarge it by a scale factor -1 from the center, you would count it from the center of enlargement. Always. It never changes, yeah. So it never changes. You always count from the center of enlargement, wherever that may be. So in this case, inside slash outside the bracket, multiplying slash dividing is just enlargement. Even if something gets smaller, it's counted as enlargement, which again might sound a bit weird. And then for part 3, if you notice, we're dividing x by 3. So again, it is still an enlargement of the x-axis in this time, because it affects the x-coordinates, by a scale factor of 1/3. Right? Because multiplying by 1/3 is the same as dividing by 3. So that's just where that comes from. So that's how you do all of those in words. Again, they haven't asked you to do it, but I've just made that question up. Any questions about... If you want, you can just copy the rules that I've written underneath. So inside, outside the bracket. And that will serve you perfectly well. It's not really a technical thing. Well, it doesn't have to be anyway. Any questions about that? All good. Perfect. No questions. Perfect. So we have a very similar question here, right? So again, we have a minimum point. It's a quadratic graph, classic. And we just have to do the exact same thing with these. With these three kind of transformations. The only probably slightly tricky one that might give you a bit of a pause is the -x one. That's about it. So again, f of x plus 3 means we're adding 3 to y. So again, we're looking at just the minimum point. So -4 plus 3 is -1, and again, x stays exactly the same. Again, with the next one, divide x by 2. Because again, if it's inside the bracket, it affects x, and it does the opposite of what it's saying. So in this case, we're going to have 3 over 2. A question that I sometimes get, and you might be thinking, is do we have to use fractions or decimals? I will say that the normal kind of notation is we use fractions instead of decimals, but you can use decimals, it's completely fine. Right? It's just that in maths we tend to use fractions. Okay. And then lastly, the -x. So I did tell you that this is also known as a reflection in a y-axis. However, the kind of easy way to think of it is you're timesing or dividing x by -1. So all you want to do is make x the opposite sign, right? So in this case it's going to be -3, -4. And that's it. So again, hopefully that's just a recap of what we had before. And Evie, did you have that hard question that you mentioned last week? We've got a few more questions to do, but we'll probably actually get that. Okay, cool. Good. Now here was one that was a bit funny. So you might notice that the first question isn't actually a... It's not a graph question. Ah, okay. It's not a graph question, but there is a graph bit afterwards, I promise. Need to get your mock papers back. Oh, that's a shame. Yeah. Okay. Wait, didn't you ask me to get the 2022 paper? Perhaps. I'll see if I can quickly... Anyways, so you have this kind of swimming pool. It gives you this shape. It's a prism. So you need to work out essentially how long it would take for the swimming pool to be completely full. We can skip this part and move straight onto this one. 22 Edexcel. Edexcel? You didn't do AQA? It's a bit harsh. Yeah. Anyways, and which paper was it? Was it 1, 2, or 3? Oh, the bad question is Edexcel. Okay, yeah, you did mention it. Okay, so I can, Lila. Yeah, absolutely. We'll do it at the end of the lesson, yeah? We'll save maybe 15 minutes of time so we can just go through a bunch of different questions if you want to. So, with this, would you be okay with working out how long it would take the swimming pool to be completely full? Are there any questions about that? It's not the worst question in the world. A bit long. Yeah? And, yeah, okay. Alright, we'll leave it then. But, here is something quite interesting. You have to pick which graph would show, or best show, how the depth of the water increases with time. So I'm actually going to drag this up here to make it a bit easy for us to see, because otherwise we have to keep scrolling back and forwards. I thought this question was pretty good. It took me a bit of thinking. But could I get your guesses right now? So no thought, just what would you think it would be? C? Okay, cool. And Evie? D. C or D? Okay. You know what? I'm actually happy with both of those guesses. That's pretty good. So you know it's not going to be linear. And the reason for that is we're looking... When you talk about depth, you're just talking about the height of the water, right? So you both noticed that it would fill up quicker at the beginning, right? Which is good. Really good. So it fills up quicker at the beginning, and then it's going to it's going to change how quickly it's filling up. However, how would it fill up after it gets to this height? So with what Evie said, it should tail off, so it kind of slows down over time. And what Lila said is that it actually becomes a constant. So if you'd like, if we ignore the triangular bit and we just have a cuboid, and we're filling it up with water constantly, it would actually fill up at a constant rate, which means it should turn into a straight line graph. So the answer is actually C. But I'm very impressed with both of your kind of logic. And we know it's not going to be this because it shouldn't speed up, right? Because obviously the volume here is much bigger, so it should actually slow down. So yeah. Honestly, Evie, D was actually my first guess until I thought about it. Yeah, so I mean, I get what you're saying. It levels off as it gets to the top, but if you think about it, it wouldn't actually level off. It would just stop at some point because the person turns the tap off, right? Or it starts overflowing. I get what you mean, but it would be a very sudden stop, right? It would increase linearly and then it would just flatten off when you get to the max height. Yeah, Lila, well done. That was a good thing. But honestly, C or D, I'm very happy with both of you picking that. And again, I didn't give you any time to think. I gave you seconds. I was like, tell me now. Boom. So yeah, I'm glad that you picked one of these two. And yeah, well done, Lila. Well done. Not bad. I'll put that back to where it was. But I'm glad... Oops. Oops, there we are. Yeah, well done. That was very good. I'm glad that you guys had that logic to put in there. So, AQA paper. I figured we'd do some transformations with the sine graph, which could be a bit more interesting. So I'm going to zoom out slightly so you guys can see the question and the actual options. So you have one of these as the graph of y equals 1 plus sine x. Circle the letter above the correct graph. So what I would... Assuming I don't throw my pen on the floor. What I would do is I would draw what the actual graph looks like. And you can draw it on top of one of the 4 diagrams if you want. It's up to you. But the sine graph does start at 0 and it goes up to 1 and then down to 0, then down to -1 and up to here. So I'll draw this on one of the diagrams, right? Now if you think about what 1 plus sine x is, if we say that f of x is sine x, right? That's the actual function bit, right? Then this graph that we're looking at is 1 plus f of x. In other words, it's just adding 1 to y. Is that logic? Does that logic kind of make sense? Is that okay? Again, there's a bit of awkward silence because there's quite a bit of a delay on this thing. Yeah, cool. So all we're doing is looking for one where the graph has just been pushed up, right? Oh, hello, Alia. So what we're doing is looking for the one that the actual graph has just been shifted up by 1. So if you look, it's going to be A. Because again, when I sketched it, if I just move this whole thing up by 1, it fits on perfectly. Well, perfectly. If my drawing was perfect, then it would be perfect. Whereas if I move it down by 1 box. All good? Perfect. I hope that this part makes sense here. So when you're thinking of what f of x is, it's always the bit with x, right? It's the bit that's changing. So in this case, 1 isn't changing, so the only thing changing is the sine x. So that's what f of x would be. I think this is also a pretty good question. A horse runs in a field. The speed time graph represents the first 12 seconds of the run. After how many seconds has the horse... It should say has the horse. Anyway, had the horse, I guess, makes sense. Run a distance of 75 meters. Cool. So what I would think of first is how do I relate distance to a speed time graph? And we went through this last week, but it's just the area under the graph. Under the line, right? Should equal 75. Okay. There are a few ways to do this. There are two ways to do this. One way that I show A-level students is all I do is I make this a big trapezium and I say that the area will equal 75 meters. There is a slightly easier way. I would break this up into a triangle and not a square, a rectangle. I'd work out the area of this triangle, subtract whatever that distance is, and then I'd work out how much more distance I would need. So let me go through that because I'm pretty sure I fumbled that explanation. The area of the triangle, half base times height, so a half times 4 times 10. So that would be half times 4 is 2, 2 times 10 is 20 meters, right? So these first 4 seconds is 20 meters. So now I'm just looking at this big rectangle here. So what's the distance I have left? Well, I have 75 meters minus 20 meters, which is 55 meters. So this area has to equal 55. Okay, so bear that in mind. Now here's where things can get a bit interesting, okay? You said 9.5? I actually don't know, so I'm going to ignore that for 1 second. I don't know, right, what the base is. I know what the height is because that's not changing. Okay, so I'm going to start with the height, 10. Now the base, I don't know, so I'm going to call it x. So 10 times x equals 55. So 10x equals 55. I don't know why I wrote that again, but you know, is what it is. X equals 5.5 seconds. Now that isn't the time, okay? What that is, so Evie, you're right, well done. Why isn't it just saying, you know what, perfect question. I didn't explain that properly. So, what I know is, up to a certain point, right, the rectangle I'm actually looking at isn't the whole rectangle. Because he runs more than 75 meters, right? So at some point, up to here, let's say, he will have run 55 meters from here to here. But I don't know after how many seconds that was. Does that make a bit more sense? You are correct. If you used 8, you would work out the total distance he ran. The horse ran. Yeah, that's my bad. I didn't explain that very well, to be honest. So what I know is that the difference between 4 and my mystery time which I'm going to call x because, yeah, I didn't really explain that properly, is 5.5. So the actual time to run 75 meters is 4 seconds plus x. Does that make sense? If I were to teach this question again, I would have changed. It is like, yes, good. It's like the average with histograms. Okay, good. I'm glad you guys get it because I actually explained this in the opposite way. So what I should have done is I should have done this step, well, this step here, I should have done that first to make it more clear as to what happened. Or maybe over here somewhere. But I hope that does make sense. That is my bad though. I didn't do that in the order I was meant to. But is everyone okay with that? So Lila and Evie, you're fine. Ali, are you okay with that? Okay. I think it's all okay. But yeah, so that's the kind of... Yeah, perfect. So yeah, this is, in my opinion, a slightly trickier speed time graph than you might normally get. But again, that's why it's 3 marks, right? But hopefully that makes sense and that gives you a bit of ammunition for that. Again, speed time graph. So Chris visits a library. He cycles there in half an hour at a speed of 12 miles an hour. Stays at the library for an hour. He then cycles home. Work out the speed in miles per hour at which Chris cycles home. So, there are a few things that we need to do here, right? First of all, what do I need for speed? What I need is distance over time. So I need distance and time, right? And exactly, well done, Lila, perfect. And because this is all in hours, it's going to have to be speed in, time in hours, right? So the time, do we have the time? Well, it takes him from 10:30 to 11:15, which is a time of 45 minutes, which is 45 over 60, so 3/4 of an hour. So far, so good? What about the distance? Well, I don't have it, right? It doesn't tell me what the distance is. Okay, does it tell me anything useful? Well, if I look at the first part, it says he cycles in half an hour at a speed of 12 miles per hour, not quite 9 miles. So in half an hour, 12 miles per hour. So again, we have speed as distance over time. So distance equals speed times time. Okay. So, okay, Evie, 8 miles an hour. Okay. Oh, well, you guys give me answers. Okay, my bad. So that's 12 times a half. So he's 6 miles from home. Right? So this distance here is 6. So my distance is 6. I'm dividing it by 3/4. So that's 6 times 4 over 3. So 6, 12, 24, 8 miles per hour. Well done. By the way, it's a paper 3, so it is a calculator paper, so you don't need to worry about doing it in your head. So, just as a proof, 6 over 3. So if you enter exactly as is, it should give you the exact same answer. A. Perfect. Okay. So, these AQA questions haven't been too bad, but they can catch you off guard, right? So the actual maths isn't too bad, but it's kind of understanding what you need to do, which can be slightly tricky sometimes, potentially. I believe there's one more question because I liked it and I just really wanted to put it in. And then I'll try and get that 2022 paper for that question. But also, Lila, if you want to post your question, we can do that as well. And again, for next week, I'm going to do that predicted paper that I mentioned you guys about that I made. Okay, so we have a sketch of y equals sine x, and we get given 2 coordinates, p and q. We need to write down the coordinates of p. The reason why I thought this might be quite useful is some students panicked on this question and got it wrong. So, might be an interesting thing to go through. So this just relies on you knowing the words. This relies on you knowing the sine graph. So when can you buy it? it's going to be available just before the next lesson, if that makes sense. So when I go through that first paper, you can then buy it from there. I'm hoping that might not be before your mocks, right? Interesting. I'll see if I can post a link on the channel when we get it up and running so you can buy it in advance. Okay? Anyways. Oh, next week is before. Okay, good. Okay. End of Feb. Oh, okay, yeah, sure. Okay, that's fine then. Next week you'll be able to get them. Perfect. So, hopefully if you know the sine graph reasonably well, you should know that it just changes between 0, 1 and -1 every 90 degrees. So it goes to 1, 90. Back down to 0, 180. Back down here, 270. Okay, so every time something interesting happens, it's just 90 degrees. So P, the y coordinate is obviously 0, and the x coordinate is 180. And again, this is in degrees because it says so. Now going backwards is the same thing, right? It's -90, -180, -270. So that would be y coordinate of 1 and -270 degrees. So again, not too tricky, but some people were caught off guard, so I thought it might be a good question to go through. So, Lila, do you have that question to hand? We can go through it now. And Evie, I'm going to get that paper. So, to Okay, I'll start with Lila's question because I didn't immediately find the paper. So a circle is centered at 0, 0. Two tangents touch the circle. Two tangents touch the circle, okay. So work out where the tangents intersect. I'm assuming that's what that means anyway. Oh. Yeah. Just classic. Imagine that circle is sent. Actually, you know what? Kind of. Okay, so -14 and 3. I'm going to say that that's over here. So we have a straight-ish line looking like that. And 13, 6 would be on the opposite side and slightly higher up. So let's say like this. And we have... Oh... Just imagine that touches for a second. Okay. Something like that. Again, it doesn't matter too much about accuracy, but let's label the points. We have -14 and 3, and we have 13 and 6 somewhere in that mess. Okay. So, what I think we should do is we need to work out the equations of both of these tangents and then equate them, right? So the best way we can do that is, first of all, I'm going to work out the... Actually, we don't need to work out the radius, but we can work out the... Never mind, what am I talking about? You do need to work out the radius. So these two meet at right angles, and these two meet at right angles. And I got all the way to the simultaneous bit and then just got lost. Yeah, fairly common. So what we can do here is I'm going to zoom in on this part over here. What I have is a big triangle. Right? This is the point 13 and 6, and this is the point 0, 0. So what I can do is I can work out the radius, and therefore... Actually, again, what I'm talking about, I can just work out the gradient straight away. But we can work out the radius as well in case we need it. In case we need it. But we don't need it just yet. So, let's start with the gradient. The gradient of r... where r is just the radius, is going to just be change in y over change in x, so it's just going to be 6 over 13. Fairly easy. So I'm going to label these lines L1 and L2. Okay? So the gradient of M1 is just negative 13 over 6. Can I ask if this was a calculator paper? Do you know? Because these numbers are pretty annoying. Again, we can do the gradient of this should be the same, right? So the gradient of this line. Okay, so let's call that R1 and R2. And then the gradient of R2, so keep in mind the gradients of the radii are going to change, right? Because they'll have different steepnesses, obviously. And that's going to be changing y over x. So again, that's 3 over... Wait, make sure I'm making sense. 3 over minus 14. Okay, yeah, I'm making sense. Okay. And then the gradient of M2 is equal to 14 over 3. Okay, good. If a calculator is allowed, that's handy. Again, it's not impossible to do without it. It's just, you know, mental maths, man. Who likes it? So here's my process for this question, just so you guys are aware. Okay, and the question is the one that Lila posted in the chat. I want to find out the two equations of lines, and then I want to equate them in order to find the point of intersection. So to find the equations of the lines, I need to get both of their gradients, and then sub in their coordinates to find their lines. So let's start with L1. Currently the equation looks like this. So to work out C, I'm going to sub in the coordinate that x is equal to 13 and y is equal to 6. So we get 6 equals minus 13 over 6, 13 plus C. So C is just going to equal 6 plus 13 over 6, 13. Okay, and yeah, I'm going to use a calculator if you don't mind. So 6 plus 13 over 6. Oh, 205 over 6, really? Alright. Again, if any of you spot mistakes, please let me know as soon as humanly possible. I've never seen this question before, so it is possible that I do something stupid. So my final equation for L1, by the way, I can see why you might get stuck on this question, if this is what the numbers are like. Okay, and that's for L1, okay? So again, if those of you that are watching, just please keep an eye out. I am prone to making mistakes, as you guys probably know. And again, if there's anything you're unsure of, again, let me know, because going through it again will help me spot mistakes, but it'll also... I mean, that's the whole point of this lesson, right? So when x is minus 14, y is equal to 3. So I get 3 equals 14 over 3 minus 14 plus c. So again, I'm going to use the same trick I had before. 3 minus 14 over 3 is 14. Which, let's do it. So we have 3 minus 14 over 3. (205 over 3). Okay, actually the numbers are pretty similar. So my equation for L2, that is a freakish emoji, man. Good lord. Okay. You know what? The simultaneous equations isn't too bad. It's not too bad. And the reason for that is when you have... honestly, I wouldn't even call it simultaneous equations. And I don't mean to say this to be a bit cocky or anything. But when you have equations of lines and they intersect, it is a simultaneous equation because y and x are the same. But you can just equate the two equations. So I can just now write 14 over 3x plus 205 over 3 equals minus 13 over 6 x plus 205 over 6. So I know you're probably looking at this and heaving a little bit. You could times the whole thing by 6 and make them all whole numbers. Right? So if this was a non-calculator question, you could easily do it by doing that. would you guys like me to get rid of the fractions? It's not necessary if you have a calculator, to be honest. But I'm more than happy to do it. In fact, maybe I should just do it just to make our lives a bit easier. So, you'd have left us fractions, yeah. You can do, but I can understand why you'd want to get rid of it. I hate fractions. They make me want to dry heave. Ah, Lila, perfect. I'm glad it makes sense. You know what? How about let's challenge ourselves a bit. Let's leave it as fractions. So what I want to do is I want to move this to this side and this to this side. Okay, so again, I'm just going to pull out a calculator. That's not the right button. We have on the left hand side we have 14 over 3x, but I'm not going to put the x for obvious reasons. And this will be plus because we changed the sign. 13 over 6 equals 41 over 6. So if you have a calculator, you can do kind of funky stuff like this. Then you have, this actually be a negative number, isn't it? Okay. 205 over 6, so 205 over 6. Subtract, because again we change the sign when we move it to the other side. 205 over 3. You get minus 205 over 6. I really should have seen that. I can't believe I just... Anyways, we'll just move swiftly on. So cancel out the over 6's. We have 41x equals minus 205. And it is divisible, right? No, that's not what I want to do. No. I hate using... Yeah, it is divisible. Cool. Yeah, I thought so. Minus 5. And then to find y, it's a bit less painful. You can sub into either one of the equations and you'll get your answer. Because again, the y values are the same. Actually, it's probably going to be pretty hideous, isn't it? Yeah, probably. Let's sub it into this first one. So we have 14 over 3 times minus 5. Wrong bracket. Plus... Also, I'm really sorry it takes me so long to type it on a calculator on this. I promise you I'm more speedy on an actual calculator. But yeah. So, did it say give it as a... Oh. Did it say give it as a coordinate? Probably. Yeah. Well, let's give it as a coordinate anyway. And look, it's 2 whole numbers, which makes me happy because it looks better than doing weird decimals. That's actually a pretty difficult question. What I'd recommend, and also for any of you that want to go on to do A-level maths, and if you want to do A-level physics as well, but any one of those 3, so if you want to do GCSE maths, obviously, A-level maths, A-level physics, draw diagrams. It is especially for A-level maths and physics, it is the biggest, most important skill you can have. So if you draw a diagram, it will make your life a lot easier. You'll be able to see things and visualize it. And again, if you're doing maths or physics, trust me, it's going to help a lot. Is this the hardest question on that topic? Yeah, I'd say so. It won't get much more difficult than that. How would they make it more difficult? Yeah, this is the hardest. I would say this is probably like a... How many marks would I say this is? This could even be like a 7 or 8 marker, you know that? 7 or 8. It's definitely grade 9. Definitely. Just more algebra, yeah. But I was thinking, like, how could they include that, right? They can make the numbers harder by changing the coordinates, but they can't really make the process more difficult. Unless it was like a quadratic, but then they'd have to give you the quadratic and it doesn't. Like it was a quadratic simultaneous equation. So a curve. Interesting. God, that's hideous. Alright. I'm going to keep trying to find... Oh my goodness, I found it. Yeah, Edexcel 2022, paper 1, last circle exam problem. Okay. Now the only thing is... I found a video, unfortunately. Wait, no, wait. Okay, I found the question. I can't. Okay, this one looks hard, I'm not gonna lie. Maybe we don't have time to do it? Yeah, I don't think we have time. No, I'm joking, I'm joking. Let's go. Okay. So, I just want to point out that I got this from like a different website. So I'm just gonna quickly snip it over. I'm pretty sure this is one you're talking about because I remember you mentioning like a bunch of different... And then all you have to do, well, all you have to do is work out the area of the two shaded regions. Is that the question? Yeah, it was a paper one question, so we have to kind of do it. If you give me two... Oh, that was close. Alright. Okay. Okay. Perfect. Okay, here we are. So, I'm going to give you a bit of a cheat. Questions like this have actually come up multiple times before. You've seen that question on Reddit after I asked you. You know the one where it had the 3 circles, perfect drawing, and it had the band going around it? Wow, that's horrible. You know what I mean, right? Actually, why didn't I just do this? See? I can use my brain sometimes. Yeah, you guys remember that question, right? You actually use something very similar in all of these really difficult circle questions, okay? And what that is you want to make equilateral triangles, okay? And that will help you. So, and if you make a bunch of these equilateral triangles, oh god, that was horrible. All right. So funnily enough, last year, I had like an A-level physics class, and these guys are year 13s, they're really, really strong, and this was in May because it was paper 1, and they actually asked me about this question, and none of them could actually solve it, and these were year 13, like further maths students, so I thought that was quite funny, obviously. But can you see that you'd make this into an equilateral? So with all of these questions, the trick is always make equilateral triangles. In every one of these hardest circle questions I've seen, always equilateral triangles. But so far, is that all okay? Now, I'm going to add some production value to this. Oh my goodness, well done. As you can see here, this is now an arc. You see what to do? Nice. Where this is 60 degrees. Why? Because all of these angles are 60 degrees. I know, right? But it's always the same trick. All of these like 7, 8, 9 markers, it's always the same. Make equilateral triangles. The thing is, it doesn't make it super easy, right? Because you still have to figure out what to do, which is tricky, right? But it's the same trick. Yeah, well, so yeah, that's a bit tricky. And also, we should keep in mind that this length here is 4 centimeters. All of these lengths are 4 centimeters. So I just realized each of radius 4 centimeters, right? So that's important information, just to keep that in mind. Where do you get questions like this? You know, I don't really like doing this. There are kind of, generally speaking, you have to pay for questions like this. There are textbooks and like online resources you can kind of pay for to get them, which is annoying. What I'm going to try and do, if it's easier, I don't want you guys paying for stuff that you don't necessarily need. I can try and find a bunch of questions like this. It's like... So next week we can do like the predicted paper, and the week after we could go back to doing like unbelievably hard questions from like history. But they're called, if you want to try and look them up, they're called grade 9 plus questions. So some other things you can look at is you can look at something called Solomon papers. There's also Winchester papers. Oh god, this new keyboard really is messing me up. Which have like the most kind of difficult questions like this. There's also, yeah. So essentially, if you look up grade 9+ questions, that will help you out. A lot of them are paid, but since I work at a school, we might have some of these on hand. So what I can try and do is I'll look for them first, so you guys don't have to pay for them. Because obviously, I don't want you guys paying, right? If you don't have to. Hope that makes sense. Okay. Yeah, so all we need to do here is work out the areas of the two segments and the areas of the sector, and you're done. So what you're going to do overall is area of the sector minus 2 times area of segment. Okay. Now, the reason why I put 2 times is an area of a segment is just the area of this arc minus the area of the triangle. Okay. So do you want me to keep going, or is that okay? I can probably keep going. You know what, let's keep going. So the sector, let's start with the sector first. If you remember, you take the angle divided by 360. So in this case we have 60 over 360. Okay, cool, I'll keep going then. Times pi r squared times pi times radius, which is 4 squared. And we can try and cancel that down. So, oh god, okay, this is not easy. Wait, no, 60 over 360 is 1/6. I'm being over dramatic. Times 16. So that would be, you can cross cancel that, you can half both of them, so you make that 8, make that 3. So it's just 8 over 3 pi. I hope that is okay. So the area of the segment now, it will equal a sector minus the triangle that's inside it. Okay. And we can work out the sector first using the exact same method. In fact, it's going to be the exact same as this, right? 8 over 3 pi. It shouldn't change. Can you guys see why it won't change? Hope so. And then to work out the area of the triangle, you're going to be using half AB sine C. So you're doing a half, A is 4, B is 4, and then sine 60. Okay? So again, stop me the second that you get stuck. Now, again, it's a non-calculator paper, but sine 60 is just root 3 over 2. So again, you can remember that trick that I want to say I showed you, but you guys already knew it. So the trick we discussed maybe might be a more legit way of saying that. So this would be 8 over 3 pi minus, so that'd be 2 times 8, sorry, 2 times 4, which is 8, times root 3 over 2. So 8 over 3 pi minus, you can cancel the 8, no, so it just makes it 4. Oh, my hand got shaky there. 4 root 2. And we're basically done. So we have 2 times the segments, take the area of this big sector and take away the 2 times the area of the segments. So we have 8 pi over 3 minus 2 times the segments, so 8 over 3 pi minus 4 root 2. Root 3, root 3. What do you mean root 3? Oh, good, yes, I see what you mean, yeah. Thank you, Evie. MVP. You know what, I could have just deleted that. Yeah, I get you now, no worries. I spotted it after you said it. I kept seeing root 3, and I was like, oh, okay. Thank you for that. And we're going to have 8 pi over 3 minus 16 over 3 pi minus 8 root 3. And that should give us our answer. Oh, sorry, it's minus 2, so I should actually make that positive. Good. Wait, did I make I didn't make another mistake, did I? No, I shouldn't have. Okay. Yeah, so 4 root 3, that's all totally fine. So yeah, this is going to be negative, right? It's going to just give me minus 8 over 3 pi. Never mind, it's going to give me minus 16 over 3 pi, sorry. Plus 8 root 3. So my answer is just going to be 8 root 3 minus 16 over 3 pi. Whew! So yeah, this is definitely a grade 9 plus question. Very tricky. Very tricky. Why is what? Sorry. Why is it grade 9 plus? Or... So essentially you're just doing 8 minus... You're right. Yeah, no, you're right. It's because I made that mistake earlier. You know, when I used the calculator. So, yeah, a second. You're right. It's 8 root 3 minus 8 pi over 3. Well done. I had it right the first time. And yeah, that would be that question. Again, just so you know, I got this from a website called Allocation. That's just where I found it. But yeah, pretty tricky. And it did take A-level students... well, they weren't able to do it, which is kind of funny. Yeah, that's definitely a grade 9 plus question. To find more of them, you can just look up grade 9 plus questions. There's also things like Solomon papers and Winchester papers, which tend to have harder questions in them as well. But yeah, okay, that was a hard question. I liked it. Was that the only one? You know, it's actually really harsh they put that in the 2022 paper. Like, it's like the first year back from COVID. And they get hit with that. And they had reduced things. No, so the reason why there are locked papers in general is for your mocks. So they lock the 2022 papers for mock exams, and they lock the practice papers for the same reason. So because normally you have multiple sets of mock papers. You set multiple sets of mocks. So I wouldn't be surprised if your mocks are going to be the locked practice papers. So if you can find out a way of like unlocking them, or, you know, there are shady things you can do. But I would genuinely not bother cheating on like a mock anyway. Is it worth revising? What do you mean, this question or like practice papers in general?